Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today we are discussing about one more important CSIR topic, that is from complex analysis. Already I told in core syllabus of the mathematical methods of physics in CSIR, complex analysis is elementary complex analysis is there. One question I took based on the topic, and the second one is the analytical function. One question I took based on the topic, and the third one is the Taylor series. One question I took based on that topic, and the fourth one is a Laurent series. One question I took based on that topic, and the fifth one I told the poles, that is the variety of the singularities I told, and the sixth one is residue, how we have to find out the residue. Today we have to discuss about that. That is the last topic, evaluation of the integrals by using a Cauchy residue theorem, right? Evaluation of the integral by using the Cauchy residue theorem. So many varieties are there within the contour, out of the contour, and so many things are there, but all those things I won't want to teach in the YouTube. If you really likes my teaching, you have to take my app and purchase my app and take the course. First you have to see what is the question. In June CSIR 2017, when they are asking June CSIR 2017, they are asking this question for 5 marks. How many marks? For 5 marks. The integral contour z e to the power of I phi z by 2 z square minus 1 dz along a closed contour tau shown in the figure. In this figure, one points are there. One point is inside +1, another point is inside -1 is there. This direction is a anti-clockwise direction. If it is anti-clockwise direction in +1, if you have to take this side, this direction, it will come it like this. This is the clockwise direction. This one is a clockwise direction. Please remember, to solve this problem, you have to understand this contour also. You have to understand this contour also. By using this, what we have to find out, first you have to see this integral, this contour integral of, this is the lemma, contour integral of z into e to the power of I phi z is divided by 2 is all divided by z square minus 1 into dz. Now we have to find out the singularities of this particular integral. How many singularities are there? How we have to find out the singularities of this point? First, denominator you have to split. How I am splitting the denominator. Z into e power I 5z is divided by 2. We have to write z square minus 1, z plus 1 into z minus 1 we have to write. Z plus 1 into z minus 1. So the both are simple poles only. So z is equal to +1 is a one singular point. Z is equal to -1 is the another singular point. These are the singular points. Which points are singular points? Now you have to observe the contour. Z is equal to +1 inside the contour only. Z is equal to -1 inside the contour only. First you have to observe whether it may be these singular points are inside the contour or out of the contour is there. You have to see. Z is equal to +1 also inside the contour, that is anti-clockwise direction, and Z is equal to -1 also inside the contour, that is also clockwise direction is there. Now we need to calculate this integration. How we have to calculate? By using the Cauchy residue theorem. What is the residue theorem? Once you have to see, the Cauchy residue theorem is Cauchy, which theorem it is? Cauchy residue theorem, right? What is that Cauchy residue theorem? Based on this Cauchy residue theorem, we have to solve this problem. Integral of contour integral of f of z dz is equal to contour integral of f of z dz is equal to 2 phi I into sum of the what? Sum of the residues at the singular point at the singular point, sum of the residues at the singular points within the contour, right? This is the formula, within the contour, right? What is that formula? So integral contour integral of f of z dz is equal to contour integral of f of z dz is equal to 2 phi I into sum of the residues at the singularities, sum of the residues at k is equal to 1 to n, you have to take sum of the residues, summation k is equal to 1 to n, residue at z is equal to zk, at z is equal to zk f of z. We have to represent in another representation also, right? So that one, above one I am writing in theoretical mode, below one I am writing in the expression mode, right? That contour Cauchy residue theorem is contour integral of f of z dz is equal to 2 phi I into summation k is equal to 1 to n, residue of f of z at z is equal to zk. How many singularities are there? How many singular points are there according to our problem? Two singular points are there. So these two singular points we have to find out what is that pole. Pole of order is equal to 1. Already yesterday I told, if pole of order is equal to 1, if pole of order is equal to 1, pole of order is equal to how much? Pole of order is equal to 1, or we also call it as a simple pole. Which pole it is? Simple pole. If it is a simple pole, the residue, what is the formula for the residue? The residue of f of z is equal to a. F of z is equal to a if n is equal to 1. What we have to write? 1 by n minus 1 factorial, 1 by 1 minus 1 factorial, 1 by 0 factorial is equal to 1. Limit z tends to a or z tends to any singular point into, so d to the power of 1 minus 1 means d to the power of 0. Here z minus a whole to the power of how much? 1 into f of z. This is the formula for a residue. What is the formula for the residue? The residue is equal to, for the simple 4 or pole of order 1 is equal to, residue of f of z is equal to n is equal to 1. Limit z tends to a, z minus a into f of z. This is the, by using these two formulas we are calculating the integration. How we have to calculate? Once you have to see what is our integration. Integral of llama z into e power I 5z is divided by 2 is divided by z minus 1 into z plus 1, z minus 1 into z plus 1 dz is equal to, which one we have to write? Here I am writing 2 phi I into sum of the residues at the singular point. First we have to take limit z tends to 1. Z tends to 1 means z is equal to 1. You have to take, this is the z minus 1. Limit z tends to 1. Z minus 1 into f of z. F of z is equal to, what we have to write? F of z is equal to z into e to the power of I5z is divided by 2. E to the power of I5z is divided by 2. Which one we have to write here? You have to see z minus 1 into z minus z plus 1. This is the f of z value I am writing. Clear? Next, plus, because it is whether it may be, you have to take, if z is equal to 1, anti-clockwise direction, that's why I have to take the plus, right? Now minus, why I am taking the minus direction? It is the reverse of the direction. Z tends to minus 1. It is a clockwise direction is there. our contour is in clockwise direction is rotating. That's why I have to take the -1. Limit z tends to -1. Which one we have to write here? So z tends to -1 means z plus 1. Z plus 1 is into z into e to the power of I5z is divided by 2 is divided by z minus 1 into z plus 1. Correct? This is the formula I am substituting. Now the z minus 1 you cancel it. Z plus 1 you cancelled it. Correct? Now you substitute the values. 2 phi I into 2 phi I into. Now you substitute wherever the z is there. No, you have to substitute 1. 1 into e to the power of I5 by 2 is divided by 1 plus 1 is equal to 2 minus, which one we have to write? -1 into e to the power of minus I5 by 2 is divided by -1 minus 2, right? Minus into minus plus minus get cancelled. Now you have to take 2 phi into I into, which one we have to write here? So e to the power of I5 by 2 is minus e to the power of minus I5 by 2 is divided by 2 is there. But to simplify this, we have to write multiply with I and divided with I. What we have to take once, you have to see 2 phi into I square, right? E to the power of I theta minus e to the power of minus I theta is divided by 2 phi is equal to sine phi by 2. Which one we are writing? Sine phi by 2. This is the sine phi by 2. So therefore sine phi by 2 is equal to 90. Sine 90 is equal to 1. I square is equal to -1. -1 into 2 phi, which is equal to how much we are writing? -2 phi. What is this integration? This integration, it will give how much value it will give? -2 phi will give. Very simple. If you understand the Cauchy residue theorem, how we have to calculate the residue, it is to calculate the integration, right? Any unwanted integrals are there. So this integral, how we have to solve, we don't know. By using the Cauchy residue theorem, simply we are finding the integration. For how many marks it came? For 5 marks in CSIR exam. If it is 5 marks questions, if you correct 10, so 50 marks you will get it. You will get the 50 marks, almost you qualify the CSIR, right? So like this exam questions are there. Please practice and apply the CSIR exam and crack the CSIR exam. What is your answer? Your answer is -25, right? Like this you have to do. So please, if you like my teaching, you download my app. My app is available on Quantum Online Academy. Quantum Online Academy from your Play Store, mobile Play Store. And then you able to see the courses. Our courses will display like this: CSR and Gate Physics, JL Physics, DL Physics, and CSR Mathematical Methods of Physics. Each and individual paper also we started, but it will take the time. Now mathematical methods of physics is available. Maybe if you have to take the 2 classes, entire the mathematical methods of portion is available on our app. You have to take the mathematical methods of physics, you have to practice it. Maybe it will take 2-3 months to finish the mathematical methods of physics. To learn this, you have to take 6 months also, because so many concepts are there. So these concepts we have to remember, we have to practice, then only we have to apply what question is there, which question is there, easy to crack the examination. So please share and subscribe our YouTube channel. Otherwise you have to learn from our YouTube channel also. For each and every topic, old one question I will take, but it will take the time. Clear? So okay, thank you. Thank you for your listening, and we will meet with tomorrow with another important topic. in YouTube. Thank you.